For the last few years, the AI race looked less like a race and more like a private track day. A small group of American labs owned the biggest models, the best chips, the deepest pockets, and most of the headlines. Everyone else was invited to watch, pay for API access, and politely admire the benchmark charts. Then Moonshot AI showed up with Kimi K3. 2.8 trillion parameters. Native multimodality. A 1 million token context window. And a promise to release the full model weights. That number is so large it sounds less like a model specification and more like the national debt of a small galaxy. But the real shock is not simply that Kimi K3 is enormous. Bigger models do not automatically become wiser, more reliable, or less likely to confidently invent a citation from the University of Narnia. The real shock is strategic. Kimi K3 suggests that frontier-scale AI is no longer a club controlled exclusively by a few US companies. The contest is shifting from, who can build a powerful model, to, who can build, deploy, price, distribute, and improve an entire AI system, and that changes the race. Kimi K3 is Moonshot AI's new flagship model. Moonshot describes it as a 2.8 trillion parameter, natively multimodal model with a 1 million token context window, designed for long-horizon coding, knowledge work, and deep reasoning. Now, before anyone starts comparing parameter counts like sports car horsepower, there is an important detail. K3 is a mixture of experts model. It contains hundreds of specialized expert networks, but it does not activate all of them for every token. Moonshot says K3 uses a stable latent MOE framework and activates 16 out of 896 experts at a time. So the 2.8 trillion figure represents total model capacity, not the amount of computation used for every single word. Think of it less like hiring 2.8 trillion employees to answer one email, and more like owning a gigantic consulting firm that sends a small specialist team to each problem. Still excessive. But at least the conference room is manageable. K3 also uses two architectural ideas that Moonshot has been developing, Kimi Delta Attention, or KDA, and Attention Residuals. KDA is designed to make attention more efficient across long sequences. Attention Residuals changes how information flows through model depth, allowing later layers to selectively retrieve earlier representations instead of simply accumulating everything in one giant mathematical junk drawer. Moonshot claims that, together with training and data improvements, these changes deliver roughly 2.5 times the scaling efficiency of Kimi K2. That is a company claim, not an independently audited law of physics. But it tells us what Moonshot wants investors and developers to notice. K3 is not supposed to be impressive merely because it is large. It is supposed to make extreme scale economically useful. On Moonshot's own published evaluations, Kimi K3 is highly competitive in coding and agentic tasks. It scored 67.5 on Deep SWE, behind GPT 5.6 Sol and Claude Fable 5 in Moonshot's comparison. On Terminal Bench 2.1, it reached 88.3, narrowly behind GPT 5.6 Sol at 88.8. On Program Bench, K3 led the comparison at 77.8, and on SWE Marathon, it posted 42, ahead of the other models shown in Moonshot's chart. In broader agent tasks, K3 also led Moonshot's reported results on Automation Bench, Spreadsheet Bench 2, and BrowseComp, while trailing Claude Fable 5 on several professional work benchmarks. That is strong performance. It is not proof that Kimi K3 is the best model in the world. Moonshot itself says K3 still trails the strongest proprietary systems overall. The company also discloses that different models were sometimes tested with different agent harnesses, reasoning settings, fallback behavior, hardware environments, and safety constraints. That matters because modern agent benchmarks do not test only the brain. They test the brain, the tools, the prompt, the software wrapper, the context management strategy, and occasionally whether the evaluation server has decided to take an emotional day off. Some K3 results are also internal evaluations. So the responsible conclusion is not, Kimi destroyed every American model. The responsible conclusion is that an open-weight model from a Chinese startup is now competing close enough to frontier proprietary systems that the differences increasingly depend on the task, the tool chain, and the evaluation design. That is a much more important development than winning one colorful bar chart. The AI industry has spent years teaching us to worship scale. More parameters. More GPUs. More electricity. more capital expenditure. More data centers large enough to alter the weather. But K3 exposes a contradiction. The model is open in principle, yet extremely difficult to operate independently. Moonshot recommends supernode deployments with at least 64 accelerators. It uses MXFP4 weights and MXFP8 activations to reduce the hardware burden, but 2.8 trillion parameters remain 2.8 trillion parameters. This is not a model most developers will download onto a gaming PC between dinner and a software update. So K3 creates two different kinds of openness. The first is legal and technical access. Developers may obtain the weights, inspect them, adapt them, and potentially run them outside Moonshot servers, depending on the final license. The second is practical access, having enough memory, networking, power, cooling, and engineering expertise to serve the model efficiently. Those are not the same thing. Open weights can reduce strategic dependence on one vendor. But extreme scale can transfer dependence to cloud platforms, inference providers, chip suppliers, and data center operators. In other words, K3 may weaken the software monopoly while strengthening the infrastructure tollbooth. For investors, that is not a footnote. That is the business model. Kimi K3 is already available through Moonshot's API. The official pricing is 30 cents per million cache hit input tokens, $3 per million cache miss input tokens, and $15 per million output tokens, with a 1 million token context window. Those numbers do not automatically make K3 cheap for every workload. Long reasoning traces and large outputs can still turn an innocent research task into a small invoice with ambitions. But the broader trend is clear. Chinese AI labs are no longer competing only by releasing good enough models at discount prices. They are pushing price competition toward frontier-grade coding, research, multimodal work, and autonomous agents. That pressures closed model providers in two directions. First, they must justify premium pricing with reliability, user experience, safety, enterprise integration, and genuinely superior task performance. Second, they must defend customer lock-in against models that can be accessed through compatible APIs or deployed through third-party infrastructure. The model layer is beginning to look less like a permanent monopoly and more like a brutally expensive commodity market with unusually opinionated chatbots. Kimi K3 arrived under conditions that were supposed to make this kind of model harder for a Chinese company to build. The United States has imposed controls designed to restrict China's access to advanced computing chips, high-bandwidth memory, and semiconductor manufacturing technology. Yet Chinese labs continue to produce increasingly capable models. That does not prove export controls are useless. Constraints can raise costs, slow deployment, limit available hardware, and force difficult engineering trade-offs. In fact, Reuters reported that Moonshot temporarily paused new K3 subscriptions after demand strained its computing capacity. That is not evidence of infinite resources. It is evidence that model capability and production capacity are separate problems. But the existence of K3 does suggest that chip restrictions alone cannot freeze software progress. Scarcity can also push companies towards sparse architectures, quantization, better caching, more efficient attention, and more aggressive systems engineering. The geopolitical competition is therefore no longer a simple contest of who owns the most GPUs. It is a contest across chips, algorithms, capital, energy, developer ecosystems, open model distribution, and the ability to turn research into a reliable product. America still has major advantages: leading chip designers, hyperscale clouds, frontier laboratories, capital markets, and global enterprise distribution. China has different advantages: a large engineering base, intense domestic competition, lower cost deployment pressure, and a growing willingness to use open weights as a strategic distribution tool. Kimi K3 does not end American leadership. It ends the comfortable assumption that American leadership is self-executing. Moonshot AI was founded in 2023 and is led by researcher Yang Jilin. The company initially became known for long context models and the Kimi assistant. K2 then established Moonshot as a serious open model developer. K2.5 added native multimodal and agentic capabilities. K2.6 and K2.7 pushed further into coding and autonomous workflows. K3 is the escalation. According to Reuters, Moonshot has raised more than $5.5 billion in total funding, recently reached a valuation of about $30 billion, and has been preparing for a potential Hong Kong listing. Those figures place Moonshot far beyond the category of interesting AI startup. It is becoming a capital-intensive platform company competing for developers, enterprise workloads, computing capacity, and strategic relevance. The immediate demand was strong enough that the company temporarily stopped accepting new subscriptions. That sounds like a wonderful problem until you remember that customers cannot pay for a service they cannot access. For Moonshot, the next challenge is not producing another dramatic benchmark chart. It is converting attention into durable revenue while expanding inference capacity without allowing cost, latency, or reliability to become the villain in the sequel. There are at least 5 reasons not to treat K3 as an automatic victory. First, the full technical report was not available at launch. Important details about training data, compute, safety evaluation, and reproducibility remain incomplete. Second, benchmark results are largely vendor-reported and sometimes use different harnesses. Third, open weights do not mean cheap self-hosting. A 64-accelerator supernode is not a community server. It is an infrastructure project with a power bill. Fourth, Moonshot lists several model limitations. K3 can become unstable if its full reasoning history is not preserved correctly. It may also behave too proactively when instructions are ambiguous. That is corporate language for, the intern may reorganize the company because you asked it to rename a folder. Fifth, Moonshot itself acknowledges a user experience gap versus the best proprietary models. That gap matters. Enterprises do not buy benchmarks. They buy predictable outcomes, support, compliance, integration, uptime, and someone to call when the autonomous agent confidently deletes the staging environment. Kimi K3 did not prove that parameter count is destiny. It did not eliminate the American AI lead. And it did not make frontier intelligence available on a laptop for the price of a streaming subscription. What it did was more subtle. It showed that a Chinese company operating under hardware constraints could build a model at unprecedented open-weight scale, compete near the frontier on major coding and agent tasks, offer a million-token multimodal system through a commercial API, and force the rest of the industry to explain why closed intelligence should remain expensive. The AI race is no longer only about the smartest model. It is about the best combination of architecture, compute efficiency, inference infrastructure, pricing, distribution, developer adoption, and product reliability. Kimi K3 turned the open model ecosystem from a follower into a strategic threat. For US labs, the message is uncomfortable. Technical leadership without cost discipline and distribution advantage can erode faster than expected. For Chinese labs, the message is equally uncomfortable. Producing a frontier model is only the beginning. Serving it reliably, funding it, and building trust may be even harder. And for investors, the biggest opportunity may not belong to whichever chatbot wins this month's leaderboard. It may belong to the company supplying the memory, networking, power, cooling, inference software, and data center capacity required to make models like K3 useful at scale. 2.8 trillion parameters make an excellent headline. The real story is that the AI race now has more than one credible starting line.